After 50, our next question is 32 question. Before going to know about 32 question, first we need to know about three factors here. So one is a RMS value, another one is a average value, and third one is a peak value. So out of these three, we will get one short answer in our external exam. So before going to know about this RMS value and average value and peak value, so why we need to define this RMS value and average value and peak value in the sense, you remember there is a difference between a DC value and a AC power supply value. Okay, so you remember in AC power supply we have a positive half cycle and a negative half cycle, totally 360 degrees. Okay, so time period. So amplitude is completely changing irrespective of the time periods. Okay, you remember that because of that only there is no any proper amplitude value at all the instantaneous time periods. Okay, but in DC you remember for all the instantaneous of time period, whatever it may be the time period, all the instantaneous of time period, amplitude is same. So you remember at this particular point and at this particular point and at this particular point, so all the particular points we can get a same amplitude, there is no any changing of amplitude. But you remember in AC power supply, so here at this particular point and this point we can consider different points on a positive half cycle, we can get a different amplitude. Here at this particular point amplitude is this much only. At 90 degrees we can get it peak amplitude, and at the same time more than of 90 degrees the amplitude will be again decreases up to 180 degrees, and here in a negative half cycle also same. So because of that we can define this RMS value and average value and peak value. So RMS value is RMS value of AC power supply equal to DC power supply. Okay, that is the major thing we need to define this RMS value and average value and peak value. Why we are taking average value in the sense, at for a positive half cycle different points, instantaneous points, we are considering different amplitude, so we can take average of that to different points, we can get it that average value is equal to the DC power supply amplitude. Okay, so you remember this one. So for AC power supply waveform having a different amplitudes, and DC is different points on a sine wave, but in DC all the instantaneous amplitude as same. Why we are going to take for AC power supply RMS value and average value for a half cycle only, but not a full cycle, because we are considering full cycle in the sense this one is a positive half cycle and this one is a negative half cycle. Average of positive half cycle and average of negative half cycle is equal to 0. After 50, our next question is 32 question. RMS value. RMS value means root mean square value. So the same RMS value is there in mathematics also. So that RMS value is completely different to this RMS value. This RMS value we are considering in AC power supply only. Okay, DC voltage is equal to RMS value of AC voltage. And the definition for RMS value is, RMS value of an AC voltage is defined as that constant voltage which produces the same amount of heat energy as produced by AC voltage when both are applied to the same circuit for the same period. Okay, so RMS value we can define for half cycle only. For full cycle RMS value is 0. This is a very important bit we can get in competitive exam also. Okay, so RMS value is equal to formula root I1 square plus I2 square plus I3 up to IN square by N. So how many number of points we are taking for a positive half cycle? Okay, So at positive half cycle and a negative half cycle, we are considering only half cycle now. So on a half cycle, how many number of points we are considering, that number of current values, and as well whatever it may be the amplitude of that particular point, and by how many number of current values or amplitude values we are considering, that number we are considering here. In the sense, we can get it R.M.S value. And same for V.R.M.S also. V.R.M.S in the sense, we are considering a voltage amplitude. Okay, so current place we can replace the voltage value. Okay, so how many number of iterations or how many number of voltage values we are considering on a positive half cycle, that number of positive amplitude voltages by that number of points we are considering, then we can get it V.R.M.S value with respect to time period.